Hey folks, this is Jay here from Chandler, Arizona, and today I'm very happy and excited, I should say, to start a new channel because I believe that with all these advances since the 90s and the 2000s, with all these advances from the software to operating systems to the internet, all the way now to large language models, AIs, blockchain, and crypto. I believe software has eaten the world. But now that it has almost eaten the world, to survive further, it needs a fundamental shift in the hardware it operates in. And it is time for the hardware to take a quantum leap, pun intended. So today I'm going to start my channel on quantum and where quantum computing is at and why quantum and things like that. My entire goal is to learn about quantum and to teach about quantum because I believe that quantum computing is what's going to be the next era of computing, where we will solve life challenges like solving cancer or getting personalized medicine out, or ensuring that our encryption is not broken, or ensuring that we have the most efficient path to go from A to B so that we are using our energy resources to the fullest. So what is quantum? Quantum today, if you look at the landscape, just as quantum, forget about quantum computing, forget about anything quantum. What is quantum, right? It is not the quantum world which Avengers has made famous. That is all kind of in fantasy world. But quantum as a term today is used to describe behavior of matter and energy at a subatomic level. It is based on a theory of quantum mechanics which says that energy and matter are not continuous. It's not continuous, but it's packets, and energy is basically the smallest unit of those packets are for energy is photon, and for mass is electrons mass, which we are made of. Quantum mechanics overall has revolutionized our understanding of this universe, and it has the potential to further revolutionize many industries including healthcare, computing, cryptography, material science, right? So, it's still at a very early stage as a whole from a quantum mechanics perspective. So, when people say quantum, they mean quantum mechanics. But there are four major pillars which are appearing in the quantum area or quantum mechanics area. Number one is quantum computing. Quantum computing will be or are today, some of them are able to solve certain problems, not all problems, which are not feasible using even a classical supercomputer uh, uh, in a very, very speedy and efficient manner. For example, breaking encryption algorithms. So it may not sound well, but breaking this algorithm gives a way of how there are maybe potential loopholes in our security, or simulating complex or very complex chemical reactions which may be happening in our body, or it may be happening in between different metals or elements of the earth, to discover new elements or to discover new treatments for a human body. Quantum cryptography. Quantum cryptography uses quantum mechanics to create secure communications so that at the communication level it is not prone to hacking. Quantum sensing is a third pillar which is emerging just now, which is basically able to measure physical quantities, right? Where we say kgs and pounds and kilograms and pounds and things like that, to a much more deeper precision than any classical sensors which may be attached to us. This can help us detect pollutants which are at such a subatomic level that we cannot even notice it. It can help us measure Earth's magnetic field. It can help us properties of materials like iron, or some other rare metal materials. And last but not least is quantum materials. Quantum materials today exhibit properties that are not found in classical materials. For example, they can conduct electricity without resistance, right? The entire point of semiconducting materials in all our computers and phones and stuff like that is because it's semiconducting. Quantum materials is going to take it to another level where will be superconducting materials, and to measure that you will need to have a field to so that we can control it, we can measure it, and from that we can figure out what problems we can solve. These properties could be used to create new types of devices which are ultra efficient transistors. Today's transistor can only go up to a certain level. We are already at a 4 nanometer transistor level. We are going to get to 1 nanometer. As soon as we get to 1 nanometer, there are going to be problems in physical problems in classical computers which you cannot do. Other things is batteries. Can we get better batteries because they are superconducting devices? So that's all for now. Quantum, once again, to summarize, quantum is an area which basically has established that the world works in packets. Energy is measured. Energy's smallest unit is photons, and mass's smallest unit is electrons. Uh, there are 4 pillars of quantum now which are emerging. One is quantum computing, second is quantum cryptography, third is quantum sensing, and fourth is quantum materials. In the next vlog, I'll talk about quantum computing. Thanks a lot, and if you like this video, please like, share, and subscribe.